Like exponent? What do you mean by that? It's an exponent in a function, yeah, but multiplied by a factor of itself. Okay, that's pretty good. So how do you explain something that's exponential to somebody else? A degree of more than one? Okay, that's pretty good. Yeah, so exponential numbers, right? These are numbers that grow or shrink really fast. So when we're talking about something that is exponential, like we've heard of exponential growth, and we've also heard of exponential decay in the terms of academic language. So exponential growth it's something that's growing pretty fast, at a pretty fast rate. Or some exponential decay is something that's decreasing at a pretty fast rate. We have both of those. But the general form for anything that is exponential, for an exponential function, is written in f of x equals some b to some exponent. So yes, there is an exponent in exponentials. That makes a whole lot of sense, right? The part down here, this is going to be our base, which is good for us. And the base has a few key points. Number one is it needs to be a positive constant. And in the example of our video game exponential function over there on the board, which number do you think represented the base? The 2. Yes, very good. It was a base of 2. So positive constant, very good. The base is not allowed to be a 1. Why is it not allowed to be a 1?
1 to the any power is 1.
Yeah, 1 to the n power is just 1 to the 1 to the 50th is just still 1, right? And it's got to be greater than 0. Okay, so it can be a half, it can be a third, it can be 2/10. It's got to be greater than 0, and it can't be 1. So that's all the stuff that needs to happen for our base. This part up here, this is called our exponent.
I have a question. What's that phrase?
Positive constant.
Oh.
Yeah, I just didn't write the word out. Positive constant. So our exponent here needs to just be any real number. And in the terms of our video game example, what was the exponent in our video game example? T over 2, which is a real number, right? Any t represents time. Time is a real thing. Divided by 2, that's still a real thing. So we have the exponent, and then we have the base. So here's the two parts of it. So the base third to the x minus 2. So all of these are examples of exponential functions. The first two are kind of really, really basic. The base in the first one is a 2. The base in the second one is an 11. But in the last two examples, it's okay for your exponent to be a variable. That's going to happen. That's no problem. And it's also okay for your base to be a fraction. That can also happen as well. So all of these are all examples of exponential functions. No problem there. So after we sort of have a general understanding of what exponential functions look like in the general form, the first thing that we learn to do with these things is evaluate them. So what does the word evaluate mean? Determine. Give me another word. Give me another synonym for that.
Solve to the best of your ability.
Solve to the best of your ability. What else you got? Understand it. Good. Okay. Yeah. When you ever see the word evaluate, you're stoked because generally it has something to do with the calculator, and it's no big deal. So we're going to do a couple of examples here. We're going to evaluate 2.2 to the 1.3. And we're going to round each of these to 2 decimal places. We're going to do A, B, C, D, and E. Letter B is going to be 43.1 times 1.8 all to the third. Part C is going to be 5 to the square root of 5. Part D is going to be 1/2 to the negative 3.2. And then part E is going to be e to the 1.2. So this one we'll do together because it'll start. There's something special going on here with this e thing. Okay? But for us, let's get our calculators out. Let me show you how to evaluate exponentials on your calculator. So turn in whatever you got there. So 2.2 to the 1.3, we're going to go 2.2. And then caret 1.3. All right. So let's do 43.1 times a 1.8. And then to the third power. And I got 251.36 when I rounded two decimal places. So you guys do part C and D, and then if you can figure out part E on your own, go to the 1.2. Okay. So there are two places on your calculator in which you can get the E button. Now E, everyone just follow along with me. Right here, see the division sign? And you see how the little highlighted yellow division sign above there is the E? If you go second and then hit the divide, you get E on your calculator and push enter one time. And you get this 2.71828, blah, 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 blah. E is a similar number, kind of like pi, right? So when you think of pi, your brain thinks of what? 3.14. When you think of E, I want you to think of 2.71 or 2.72, okay? It is a natural number that occurs. We're going to talk a lot about it, but that's the general. You need to know that E is about 2.72, all right? So on the calculator to evaluate E, you have two choices. You can either go second divide, caret, and then 1.2, and push enter. Or you can go second ln, which stands for natural log, and then there's an E there with a caret involved. Then you can just put 1.2 in there as well. So however you do it, you get the exact same thing, decimal for decimal. So there's two ways to access E on the calculator. So for us, that's like 3.32 for right now. All right? Okay, great. You guys feeling good about evaluating functions? Yeah, no problem, right? That's the easy part. Okay, now we're going to graph. We're going to spend the next half hour on graphing these things. All right. So when we were graphing exponential functions, I gave you a handout, and the handout I gave you is this one right here. So find this on your table, and let's talk about this. Whatever you got to do over there. Okay, use your straight edge, and give yourself a coordinate plane. Okay, and for the first one, we're going to create a table. And hopefully we're going to look at some patterns here that we can figure out. So we're trying to graph the generic, very, very basic exponential function f of x equals 2 to the x. So what values could I plug in here to sort of take a look at this function? What's some good values? 1. Okay, that's a good value. Give me another one. 2. How about any others? 3. Okay. -1. That's a good one. 0. That's a great one. Yeah. And let's give me another -1. -2. Okay, good. That's good enough for now. Okay, so let's evaluate each of these, and then we'll put them all on the graph. So at 1, what do I get for f of x to my function? So what is f of 1 going to be? 2. Yeah, very good. If I plug in a 1 here, 2 to the first power is 2. What's 2 to the second power? That'd be 4. If I plug in a 3, 2 to the third power? 8. Yeah. 2 to the third. 2 times 2 is 4, 2 times 2 is 8, right? How about -1? Ooh. Yeah, so, yeah, remember, right? A to the negative n is the same thing as 1 over a to the positive n. So that means in this case, if I had 2 to the -1, that's the same thing as 1 over 2 to the positive 1. Well, how much is that? That's just a half, right? So all that's going to be a half. So I'm lost that rumor. What about 0? Plug in 0, what am I going to get? 1. That's interesting. And then how about -2? What would I get? I'd get 1/4. Good. Let's plot all these on the graph. So our graph paper is so nice, I think. So 1, 2. 1, 2. There we go. That one's on there. 2, 4. 1, 2. 1, 2, 3, 4. That one's on there. 3, 8. 3. 1, 2, 3, 4, 5, 6, 7, 8. All right. -1, 1/2. -1, 1/2. Okay, that's right there. -2, 1/4. That's below that, huh? All right. And 0, 1 is right here. Okay. So when you have that information, go ahead and connect all those dots there. And you should get something that looks like this. And now we can talk about it. All right. What can we say about this graph? What can you say at all about this graph? I'm not sure. Is it really half a parabola? No, it definitely increases, right? It gets bigger. So would you say this is an increasing or decreasing? This is an increasing graph. So let's talk about all these things. Okay, it's increasing. Good. Increases exponentially. Okay, I like that. What's the domain? Very good. The domain is all real numbers. What's the range? Yeah, all real y such that y is greater than 0. So if the range is strictly greater than 0, is there an asymptote anywhere? Yeah, where's the asymptote? Very good. That's a horizontal asymptote right here, and that's the line y equals 0. That's very good. All right, there are 2 anchor points that will appear in every graph that is of this nature. And those points are 1, 2 and 0, 1. So this point I call, these are your anchor points. So you might want to star these points. These are the points that we're going to use for when we graph these, okay? 1, base is what I call this one. And then 0, 1 will always be on there. So why am I saying 1, base? What do I mean by that? Yeah, 2 is the base, right? So I'm saying the base right here is 2, okay? So 1, base. So those are the 2 anchor points that we're going to use, okay? Here's part B. Using the 2 anchor points and only those 2 anchor points, I'd like you to graph f of x equals 1/2 to the x. So how is this one different than part A? Yeah, the base is a fraction, but it's still positive, right? But it's between 0 and 1, right?
Is there always a 0 one and then 1?
Yeah. So whenever we have these basic ones here, right? Whenever you have like b to the x, you're always going to have 0, 1, so 0, 1's on the graph. And then 1, base, so 1, half. So, and we already know that there's a horizontal asymptote there at the line y equals 0. So this graph, it looks something like this, as a quick little sketch here. So how is this graph different than this graph over here? What's the difference? It's reflected over the y-axis, true, and what else? This is a decreasing graph, right? Yeah. This graph is decreasing. So if our base is greater than 1, that implies that we're going to have an increasing graph. If 0 is less than or base, which is less than 1, that implies we're going to have a decreasing graph, just like we did here. So it's decreasing. Our domain is the same, all row numbers, right? Our range is the same, but this graph happens to just be decreasing. And so you can investigate, right, as you, like, if you want to make a table here, f of x, as x gets big, like 5, then we get like 1 over 32. So the number gets closer and closer to 0, but never quite becomes a 0, never quite goes below it. So that's why we have a horizontal asymptote at the line y equals 0. Okay, so for the last part here, we're going to graph some more complex exponential functions. Okay. Actually, here's what I'm going to do. I want to do this. Okay. Oops. There we go. Get rid of this one. All right, so let's see if we can do this. Can you write down any equation that you see, either the blue, the red, the green, or the black? Can you write any? Let's go over it. You guys got them all. I heard them all out there. All right, blue one. What's the blue equation for the blue one? 3 to the x. Yeah, how do you know that? Because, yeah, 0, 1, and 1, 3 is on the graph, right? 1, base on the graph. So that's going to be 3 to the x. How about the red one? 7 to the x. F of x equals 7 to the x. Good. Because 1, 7 is on the graph. 1, base. 1, 7 is on the graph. So that's 7 to the x. Making sense? Okay, how about the black one? How do we know what this one is? First of all, we know it's going to be a fraction, right? To the power, right? It's a fraction because it's between 0 and 1 because it's decreasing. So what is that fraction? 1, what? Yeah, it looks like 1/3. You're exactly right. So that'd be 1/3 to the x. And then how about the green one?
How do you know if it's decreasing? Is that always a fraction?
Mm-hmm.
How do you know?
Yeah.
Wait, oh, do you know that because it's like stops
For the black one, I know that this looks like the point 1 comma 1/3 to me. Right there, that point.
But you see when x equals -1, it's 3.
And when x equals -1, you get 3. Exactly.
Yeah, that's
So
three.
then how is the green one 1/4?
It's not 1/4. The green one's not 1/4.
Then how is it 3?
It's 3/4, right? Good. So f of x equals 3/4 to the x.
Yeah, I'm not sure where you're looking. Are you looking at the top part of it or the bottom?
I'm looking right here. Because at the 1, it's like 3/4. If I had to take a guess, that's where I would look. Does that make sense? That point looks to me like coming into play. All right, so before we even dive into this thing here, first let's figure out what is the base function that we're going to use here. What's the base? 3. Excellent. So the first one that we're actually going to graph is f of x equals 3 to the x. That's our base function. So we're going to use different colors here because we're going to use transformations. If you don't have colors today, that's okay. But, pencil, red pen, crayon, marker, whatever. So I'm going to graph, number 1, a base function of 3 to the x. So I'm going to go 0, 1, and I'm going to go 1, comma 3. And those points right there, those are going to be my anchor points. All right? So my anchor points are 0, 1, and 1, comma base. All right, now we have to kind of figure out what each of these pieces do. So what is this -2 out in front? What is that going to do in my graph? Yeah, this is going to go down 2 units. Okay? What is this x to the -4 up here? What's this going to do to my graph? Yeah, this is going to be right. Okay, so here's what I'm looking at, right? I'm looking at this thing right here. This tells me what I'm looking at. Yeah. So the piece out in front, that is going to go up or down, depending on if it's positive or negative. I got this constant part in the back here, this plus or minus c. It's a horizontal shift. Left if it's positive, right if it's negative. And I have my base function. So this little diagram here is going to be very, very helpful in figuring out what each of these are going to do. Huh? Yeah, for sure. You should use it. Nope, you should memorize it by then. Yeah. Okay, so number 2, there's what should we do next? We have to do 4 units to the right, and we have to do 2 units down. Yeah, let's go for the right. So I'm going to build this function. I'm going to say, okay, f of x now 3 to the x minus 4. So the cool thing about my 2 anchor points, all I have to do is move those 2 anchor points 4 units to the right. So 1, 2, 3, 4. 1, 2, 3, and 4. Right? You guys follow along? Cool. And notice that my horizontal asymptote has not moved. That stays right there. That's still the line y equals 0. Okay, so now I have this new exponential function. Oh, this should be in red, by the way. This new exponential function that represents the graph 3 to the x minus 4. The black one represents the graph 3 to the x.
So now you make another transformation.
I'm going to make another transformation. You're right. What am I going to do to it?
Make it go down by 2.
Yeah, I'm going to make it go down 2 units. You're absolutely right.
Wait, how do you know that it shifts 4 to the right instead of...
Because it's saying, it says x minus 4. So if it's negative, it goes right if negative. So I got 4 units to the right. And then the last thing I have to do is shift this whole thing down 2 units. So that's going to be in blue for me. So take each anchor point, go down 2, 1, 2, 1, 2. But there's something else that moves down 2 units as well. What is it? The asymptote. So the new asymptote, instead of y equals 0, is going to be y equals -2. So I have a new asymptote, I have a new function, and it looks like this. And this is 3 to the x minus 4, and then minus 2. So there is a transformation of 3 to the x into 3 to the x to the negative x plus 1. So use transformations and graph 2 to the negative x and then plus 1. Yeah, you can. If you want to write it like that, you can go 1 plus 2 to the negative x. You can make it. That's the same exact thing. No. I'm keeping it on the same side of the equation. So okay, so we got about 4 minutes left of class. Check it out. Here's what you should have had. You should have started with y equals 2 to the x. That's my red graph there. So you should have had 0, comma 1, and then 1, comma 2. So there's my red graph. Moves it up to, or just a basic base function. And then I did 2 to the negative x, and then moved it up 1. So 2 to the negative x is a reflection. So here, I'll take this back down. So I'll erase that for you. Okay? So there's 2 to the negative x. That would just be a reflection over the y-axis. And then, finally, I did 2 to the x, and then finally a plus 1 on the back end. Whoops. Which moved the whole thing up 1 unit. So you should end up with something that looks like that. And the horizontal asymptote is the line y equals 1. So therefore, the range is all real y's such that y is greater than 1. Okay, guys, feeling pretty good about this?